Okay, let's solve another sample problem. We have here, the figure shows the layers of soil in a tube that is 100 millimeters by 100 millimeters in cross section. Water is supplied here to maintain a constant head difference, a total of 400 millimeters across the samples. The hydraulic conductivity of the soils in the direction of flow through them are tabulated as shown. We have to compute for the equivalent hydraulic conductivity or the total hydraulic conductivity for these three soil samples, the hydraulic gradient, the rate of water supply in cubic centimeters per hour, the height at the piezometer attached between soil A and B, and that is H1, and the height at the piezometer attached between soil B and C, that is H2. Okay, first one is to analyze the given flow in our given figure. And the flow will come from here, and then it will pass through this direction, and then it will pass through soil A first. After that, it will go through soil B, and then after that, it will pass through soil C. Therefore, the water will flow through the soil layers one at a time. And for that, we can say that the total flow is equivalent to the flow in layer A, also equivalent to the flow in soil layer B, also equivalent to the flow in our soil C. But flow rate is the product of the cross-sectional area and the discharge velocity. That is for total parameter for soil A, for soil B, and then for soil C. But if we can see here, the total flow having a cross-sectional area, the cross-sectional area is perpendicular to the given flow. So this is the flow, and this will be our cross-section. And the cross-sectional area for total parameter here is also equivalent to the cross-section in layer A, also equivalent to the cross-section in layer B, and also for layer C. Therefore, we can cancel our area parameter. And then we can see that the total discharge velocity is also equivalent to the discharge velocity for each soil layer. But discharge velocity is a product of hydraulic conductivity and hydraulic gradient. And hydraulic gradient is the ratio of the head loss with respect to the length. And that is KH over L for total parameters, also for soil A, for soil B, and KH over L also for soil C. And then, in this equation, the unknown parameter is total hydraulic conductivity. We already have the total head loss, the length for total parameter equivalent to 600 millimeters, the hydraulic conductivity for each soil layer, and also their length mismo. So, for us to get the value of hydraulic conductivity in total parameter, we need to analyze first the head losses for each soil layer. And to get the head losses, we should analyze the pipe attached between or attached at the ends of each soil layer. For example, for soil A, these are the ends of soil layer A, and the pipe attached at the ends is these two pipes. And the water level or the vertical distance of the water levels in these two pipes is what we call the head loss of soil A. For soil B, these are the ends of soil B, and the pipes attached between or at these points are these two pipes. So the vertical distance between these two water levels is what we call the head loss of soil B. And for the soil layer C, that will be our head loss of soil layer C. Therefore, we can see in our problem that head loss of soil A plus head loss of soil B plus head loss of soil C is a total head loss. Therefore, we have an equation there. You can say that HA plus HB plus HC is total H. But in this equation, we can analyze the equation of H head losses. For head loss of soil A, takpan lang natin itong dalawang to and then cross multiply to get our equation. Therefore, we can say that HA is equivalent to cross multiplying KH over L for total parameter multiplied by LA over KA. So same for head loss of soil B. You can say that head loss of soil B is KH over L, total parameter LB over KB, and head loss of soil C is KH over L multiplied by LC over KC. So substituting these equations into this equation, we will get KH over L, total parameters LA, plus KH over L, LB over KB, plus KH over L, LC over KC equivalent to total H. And we can see that each terms has a parameter for total head loss. Therefore, we can cancel that. In this side of this equation, it has a common term, K over L. So factoring out K over L, natira dito is LA over KA plus, for this term is LB over KB, and then for this term is LC over KC, and that is equivalent to 1. Getting the value of K, or the equation of K, cross multiply lang natin, can get that K is equal to L over LA over KA plus LB over KB plus LC over KC. And that will be the formula of hydraulic conductivity for this given direction of flow. Actually, this formula is already derived. Na kapag ganyan mismo yung flow, which is vertical flow, alam mo na dapat natin gagamitin formula since this is under the case of equivalent vertical hydraulic conductivity. Kapag nandito yung flow natin, that will be under horizontal direction of flow. So, iba yung formula gagamitin doon. So, for the first unknown, substitute lang natin. K will be total length, given the problem, 200 millimeters times 3 over LA, 200 over KA, plus LB over KB, and then plus 200 millimeters over KC, and that computing for the value of K, you will get a value of K which is 3.40 times 10 raised to negative 5 centimeter per seconds. And that will be our first requirement, the value of equivalent hydraulic conductivity, and that is for the vertical direction. And then second requirement is to compute for the value of hydraulic gradient. And we know that hydraulic gradient I is the ratio of the head loss with respect to the length. The head loss will be equivalent to 450 millimeters over the length, a total of 600 millimeters, and that will give a value of I, which is equivalent to 0.75. The third requirement is the rate of water supply in cubic centimeters for R, and that is Q, and flow is the product of K, I, and cross-sectional area, equivalent to substituting the values. Already computed K, 3.40 times 10 raised to negative 5 centimeter per seconds, multiplied by I, 0.75. The cross-sectional area, 100 millimeters by 100 millimeters. So, the unit should be in cubic centimeters per hour. Since naka-centimeter per seconds na yung ating hydraulic conductivity, make our cross-section in centimeter unit. Therefore, and 100 millimeters is also equivalent to 10 centimeters. Therefore, cross-sectional area is 10 centimeters by 10 centimeters. And then we will convert seconds into hour. That is multiplied by 3,600 seconds is to 1 hour. And that is Q will be equivalent to 9.167 cubic centimeters per hour. And that will be our third requirement. For our fourth requirement, we have to compute for the value of H1, the height at the piezometer attached between soil A and B. And from the figure, we can see that head loss of soil A plus H1 will be the total head loss. So our equation there will be HA plus H1 equivalent to H. For us to get the value of H1, that will be H minus HA. That will be 450 millimeters minus HA. For you to get the value of H1, get first the value of HA. And we already derived the equation for HA. So substituting the value of HA, that is KH over L for total parameters, multiplied by LA over KA. So substituting now, we have hydraulic conductivity for total parameters 3.40 times 10 raised to negative 5 centimeter per seconds, multiplied by the total head loss 450 over the total length, multiplied by the length of soil A 200 millimeters over hydraulic conductivity of soil A. So computing, we will get a value of HA will be equivalent to 25.46 millimeters. Therefore, substituting now, we will get a value of H1, 450 minus HA, that will be 424.54 millimeters. And that will be our fourth requirement. And then the last requirement is to compute the height of water at the piezometer attached between soil B and soil C. That is H2. And H2 is also equivalent to HC. So compute HC for you to get the value of H2. That is H2 equivalent to HC KH over L for total parameters multiplied by LC over KC. So substituting now the parameters, H2 will be equivalent to multiplied by H, total head loss for 50 millimeters over the total length multiplied by the length of soil layer C, that will be 200 over the hydraulic conductivity of soil C, 1.2 times 10 raised to negative 5 centimeter per seconds. So centimeter per seconds will be cancelled, millimeters. The resulting unit of head loss of 2 or soil C is in millimeters, and that will give us a value of 424.40 millimeters. And these are the requirements for the given problem.